And so let's see one practical example of the kind of things that we are actually going to see when we work in problems. Let's compute this product. 1 plus x squared plus small o of x squared, right? Squared, right? So then we have 1 plus x squared plus o's x squared, right? And then we have plus x squared plus x cubed plus x times o of x squared, and then plus x squared plus x cubed plus x fourth plus x squared times o of x squared, and then we have plus o of x squared plus x times o of x squared plus x squared times o of x squared plus o of x squared times o of x, right? Now we can use these rules to simplify things, right? So then we have let's see, let me write it here, right? We have one, let's collect the terms with the same powers, right? So this is 2x plus 3x squared plus 2x cubed plus, and then we have 1x to the fourth, right? And then we have o of x squared, small o of x squared here, and x times small o of x squared, right? But then x times small o of x squared, right? This is h times this is x times small o of x squared, using the last property is small o of x cubed, right? X goes inside multiplying. But small o of x cubed is small o of x squared, right? So then we can write this as small o of x squared, right? So this thing is small o of x squared. Now we can use the same argument. This thing is also small o of x squared. This thing and this thing, using the same argument, are small o of x squared. This is small o of x squared. Okay, this too. And what happens with this? This is small o of x squared times small o of x squared. Remember property C, small o of g1 times small o of g2 is small o of the product, small o of x to the fourth. But this is again small o of x squared, or in other words, small o of x squared, right? So all of this combines to say that all of this is 1, 2, 3, 4, 5, 6, 7 times o squared, but 7 times o squared, or small o of x squared, sorry, is equal to small o of x squared using the first property, right? But we can also simplify this and this, because both these guys are small o of x squared, right? And we can't, once you have an expression with small o of x squared, that includes terms with x cubed and x to the fourth, right? So that you can't maintain these guys in the expression, because you don't know what's the coefficient of this in this, right? You're neglecting all of them from the start, right? So you can't keep them, right? Your expression can only reach up to x squared, and everything after that in terms of higher powers of x are going to be neglected and included in the same term, right? So the last thing is to collect everything. So everything is like this. This is the result of the square of this. 1 plus 2x plus 3x squared plus o of x squared, right? And this is the kind of, once you get used to these manipulations, you will get very fast in this, right? So you tried multiplying this. Let me start doing again, right? So, because once you write one time small o of x squared, you don't need to write it again, right? So this is 1 plus x squared plus small o of x squared, right? And then we have x that multiplies x that multiplies x squared, and then we have x that multiplies x squared, that's x cubed, that's a small o of x squared, we don't really need to care about that, right? And then we have x squared that multiplies 1, and then x squared, everything that it's going to multiply, it's going to be small o of x squared, so we don't really need to care about that. And then everything that multiplies small o of x squared is going to be small o of x squared. So we just have that, and from that we just collect the terms, and we're done, right? So this looks like magic, but it's actually well fundamentally we've seen these properties, and that's how it works. And as you get more familiar with this will become easier to you, right? So just one last note: if I say that f is smaller of 1 when x goes to a, what I mean is the limit when x goes to a of f is 0, right? Because the limit of f divided by 1 is 0, right? So remember that. There's some handy way of express this. Okay, so that's the end of this video.